Hello everyone, welcome back to our Calculus 2 course this semester. For this week video clip, I'm going to talk about two sections of chapter 7, section 7.2 and 7.3. It's about trigonometric integrals and trigonometric substitutions. Okay, so let's start with 7.2, a trig integral. 7.2. Trigonometric integral. So as you see trigonometry, right? So we're gonna deal with trig functions like sine, cosine, tangent, cotangent, secant, cosecant, etc. So it requires you to know some trig formula, obviously, and I gotta be frank to you, but it's not easy. It's hard. However, the good thing is it has formula, so it turned out to be easy if you know the formula. So I'll show you the formula. It's like a recipe. Whenever you guys see that type of problem, you just follow the step. Then be careful with your algebra. Then you should have the answer. But as I say, trig. So you gotta know some formula. Okay. So let's start with the first type. If you see an integral that involving sine and cosine, say sine x raised to the n power, and then cosine of x raised to the n power dx. Okay. Say example, sine cube of x times cosine square of x, those kind of things. Okay, and then any exponent. Then we have a method to solve the problem. The key is this. We look for the odd exponent. Okay. I'll put it this way. This is like my own words. So say, break the odd exponent. Okay. All right, that way. Let me give you an example, and then I'll show you what I mean. Example. Say I got an integral of sine square x times cosine cube x dx, and then calculate that integral. Okay, dx. Okay, so amongst those two, we have an odd exponent, but we're gonna break it out. Always break it this way for me. So I'll write this sine square x. I'll leave it alone. I'm gonna work with the odd exponent for cosine. I'll break it out as cosine square x times cosine x dx. Always break it out this way. Okay? So if you got like cosine to the 5th x, you're going to break it out as cosine to the 4x times cosine of x. Just one single cosine and then the rest in there. So if you got cosine to the 7, it's odd, right? You break it out in what? Cosine to the 6 times cosine x. And of course the same thing for sine. If sine to the 7, you break it out as sine to the 6 times sine x. Okay? Always break the odd out. And what if both of them are odd? You choose one. Okay? Both of them are odd, then you can choose either sine to break or cosine to break. If both of them are even, then we don't know how to do it yet. For now, the formula only works if you have one of those exponents is odd. Okay, so in here I give you example where cosine is odd. So I'm breaking it out this way. All right, and what is that good for? You know that for sine and cosine, derivative of cosine is negative sine. Derivative of sine is cosine. You know, something like that. And something I think they call it double angle formula. So sine square of x is 1 minus cosine 2x over 2. Yeah, right. Cosine square of x equal to 1 plus cosine 2x over 2. Those kind of things. Okay. So those are some helpful formulas. Or maybe this as well. Sine square of x plus cosine square of x equal to 1. I'll just try to write some formulas, some trig identities involving sine and cosine. That's maybe helpful for this type of problem. Okay. So one more time. The first type of trig integral you may see is what? Sine, cosine, raised to some exponent. And the key to tackle this type of problem is to break out the odd exponent. If you have sine is odd, then you break out the sine. If cosine is odd, break out the cosine. If both of them are odd, then you choose one. If both of them are even, then we have to find another way. Okay, so in the example right here, I got sine square, cosine cube. So I see the square is even, I'm going to leave it alone. Cosine cube, cube 3 is odd, so I break it down as a single cosine and then times cosine square. See why it's helpful right here. This is cosine dx, right? I'm going to do a u sub. I'm going to let u equal to sine x. You know why I let u equal to sine x? Because I know the derivative of sine is cosine. So if I take the derivative of that, du is equal to cosine x dx. This is the one that I'll just break out right here. So if I do that sub, this problem becomes what? Integral sine square right here is u square. Cosine square, remember the identity that I just gave you? Cosine square x plus sine square x equal to 1, right? So cosine square x equal to 1 minus sine square x, which is 1 minus u square, because I let u equal to sine x. So this is u square, cosine square is 1 minus u square, and then cosine x dx becomes, cosine x dx is du. You see what we have right here? We just converted a trig integral back into a polynomial integral. So this is integral of u squared minus u to the 4th du, and then you can take care of this problem easily. Does that make some sense to you when we try to give you an example of working with the type of trig integrals involving sine and cosine raised to some power? You see the example right here. Let me give you another example with higher exponent. Okay, and again the idea is pretty much the same. We may have to do more work if we have higher exponent. Let's try one. What if I have this integral of sine to the 7x times cosine to the 4x dx? Now, in this second example, the odd exponent falls into sine, right? And the even one is on cosine. So I have to work with sine. I gotta rewrite it this way. Integral sine to the 6x cosine to the 4x, and then sine x dx. I put sine x next to dx because this is what I'm looking for. See, sine to the 7 is sine to the 6 times sine x is sine to the 7, right? So I want to have sine x dx. What is my substitution since then I have sine x dx? I have to let u equal to cosine of x. Okay? So that my du will be negative sine x dx. Now I can take care of the problem. Okay? So this will be integral. Okay? So we have to work on sine to the 6 and then cosine to the 4 and then sine x dx, right? Let me work on the side before I put it in. So I know that cosine to the 4th of x is just u to the 4th. This one, this part right here, is u to the 4th. Okay? And sine x dx, sine x dx is just negative du. This is du equal to negative sine x dx, so sine x dx is negative du. Okay? Now, the tricky part is what about sine to the 6th of x? Sine to the 6th of x, and here's how we take care of it, equal to sine square of x raised to the 3rd power. And you know how to, why we need to sine square? Because I can convert sine square to cosine, which is 1 minus cosine square of x, and then raised to the 3rd power, which is 1 minus u square, and then raised to the 3rd power. Because cosine is u, so cosine square is u square. Now everything back to u. I'm gonna rewrite it right here. Go down a little, okay? This is integral sine to the 6 is 1 minus u square. Let's raise to the 3rd power cosine to the fourth is u to the fourth, okay? And then sine x dx is negative du, so I'm going to write du here and then put a negative in front. See? No more tricking here. Now you have to factor everything out, combine all like terms, and you integrate using the power rule. You have the answer. No more tricking here. Alright, that is the first type of trig integral that you see in this section 7.2. Let me move on to the second type. The second type of problems involving secant and tangent. Okay. So the second type is integral tangent of m, secant of n, x, tangent of x, right, times secant of raised to the n power of x, and then dx. Okay, this one's gonna be a little bit trickier than the previous one. First of all, let me bring down some trig identity that's gonna be helpful for this type of problem. So what do we have? We have cosine square x plus sine square x equal to 1, right? So if I divide both sides by cosine square, I got 1 plus tangent square x equal to 1 over cosine square, which is secant square of x. So you see, I got one equation that's involving secant and tangent. And then derivative, tangent x, derivative is secant square of x, secant of x, derivative is secant x, tangent x. Okay? Or maybe more, but let's start with some of those right here. Okay, and how do we take care of this problem? Is what? Integral of tangent raised to some power with the secant raised to some power, alright? So it depends on, again, m and n, which one is odd, which one is even, but it's going to be different from the previous one. Okay, let's start with this. If n is even, let me erase this, okay? If the exponent of secant is even, then break the secant. If the tangent, exponent of tangent is odd, then break the exponent of tangent. If it's not the case, then we have to find a different method. Okay, so let me start with this. If n is even, exponent of secant is even. All right. So example. Then break the n. Okay. This is like my little key, so I put it in quotation mark. Example. Say I have integral tangents x, I'll make it simple, right? The first example, just m is 1 here, times secant to the fourth of x dx. I try to emphasize the exponent of secant right here to the fourth. So I'm gonna break out the exponent of, make it tangent squared, make it a little bit harder. Okay, tangent square of x times secant to the fourth of x. Of course, tangent is easy, so it should be a problem. Tangent square of x, secant to the fourth of x dx. And I see what? N is even. The exponent of secant is even. Okay? So I have to tackle that exponent of secant right here. I'm going to write this way. Integral of tangent square of x times secant square of x times another secant square of x dx. Okay? So in here I give you to the 4. What if you got secant to the 6? Secant to the 6 of x dx. And you're going to break out secant to the 4 of x dx times another secant square of x dx. Okay? Always have a secant square, and the rest is on the other secant function. So if I got secant to the 8, it's even, right? Always even. And what? This is secant to the 6 times secant square. The point is, I want to have the secant square of x dx because I know that the derivative of tangent is secant square. So I know the derivative of tangent is secant square. I want to do a u sub. I'll let u equal to tangent of x. Then I know that my du will be secant square of x dx. Now, I'm going to take care of this problem. See what we got. Secant square of x dx. Secant square of x dx is just du. Okay? And tangent square of x is just u squared. Tangent square of x is just u squared. What about secant square of x right here? Secant square of x, we know that secant square is 1 plus tangent square of x, which is 1 plus u squared. Then you have everything. Integral tangent square is u squared. Secant square of x is 1 plus u squared. And then secant square of x dx, this one right here, the whole thing, is du. You see what? We are back into an integral with polynomial inside, and this is very doable. Just factor them out. This is the u squared times u to the 4, and you can integrate it. Okay? So the first case for the type tangent secant is what? If the exponent of secant is even, then you tackle the exponent of secant. You break it out as secant squared times the rest of the secant power. Okay? Let's move on. The second case, if the exponent of tangent, which is m in this case, right, m is r, then break tangent and secant. Okay. So, second case, if the exponent of m is r, then you're going to break both tangent and secant. This is an example. If I have integral tangent cube of x times secant cube of x dx. So in this example right here, the exponent of secant is odd. It's not even, so I'm not going to break the secant, okay? But I have the tangent is odd. So this is how I'm going to break. Integral tangent square of x, secant square of x, times tangent x, secant x, dx. As long as I got the tangent exponent is odd, now I'm going to break both tangent and secant, one each. So I'll take one tangent away, I got square, I take one secant away, I got secant square left, and then tangent secant. And the purpose is it's tangent x secant of x is derivative of secant. Okay? Then my sub is I'll let u equal to secant x. You see why? Because I know that the derivative of secant is going to be tangent x times secant x. Okay? So du is tangent x, secant x, dx. Okay. And of course, secant square, that's what we have right there, is going to be u square, and tangent square of x is secant square of x minus 1. I use the formula that I gave you from the beginning, which is u squared minus 1. Now you can bring from back to polynomial. Integral of u squared minus 1. Secant square is u squared, and tangent secant x dx is going to be du, and this is solvable again. Okay. You may have a question. Why do we need tangents to be odd? Because when it's even, then when you break it out, it becomes odd right here. We won't be able to solve yet. So if it's odd, say we got like to the 7, make it hard, okay? Then this one you break it out. And we don't care about the exponent of secant. Just need tangent, exponent is odd. So this is 7, and what? It's just 6, okay? So make it out, right? Tangent 6 times tangent to 7. Secant cube is secant squared times secant x. All right? Then what happened in here? We have secant square of x equal to this, so tangent square is equal to secant square minus 1. So tangent to the 6 of x is going to be tangent square of x raised to the third power, which is u squared minus 1 raised to the third power. So you see? So as long as you got exponent of tangents is you take out one tangent, you're going to have an even exponent left over for tangent. You can always convert it back to the u sub, and then you can solve. Okay, what if m is odd and secant is even? Now you feel free to choose. So m is odd, then you can break the tangent, or if secant is even, then you can go break this, the secant. Then you have two ways to take care of this problem. What if you have the other way around? If tangent is even and secant is odd, then, well, we're going to find another way to solve it. We don't have a formula right here. It depends on the problem. Okay. Now, let me show you some, just put down some, I would say, typical integral. That's, you can consider as a formula. Just try to do this one, and if you can memorize it, you can remember, it's going to be helpful. Okay. Integral of tangent of x dx. It's one of those. Alright. And how you solve this one? This is actually, I put it in the quiz a couple years ago. Integral, you think of it as tangent is just tangent, right? No secant, so think of it as sine x over cosine x dx. So I have like sine x dx right here. I'll let u equal to cosine x. Then du is negative sine x df, and this integral will become integral cosine the bottom, right? So 1 over u sine x dx is du with a negative in front, then you can solve. And this is going to be equal to what? 1 over u integral is going to be ln of u, right? Plus c with negative. You have negative ln of cosine of x plus c. If you put the negative inside, it's going to be, I can erase this, ln of cosine of x to the negative 1. Right? For the log, negative inside becomes the exponent, and cosine negative 1 is ln of secant of x, either way of writing. Usually I'll write this way, but I see the book write this way, so I show you both. It's the same. Okay? So, one of many useful integral that you will need to know. It's going to save you time with integral of tangent. So if you don't know, then you do all the work right here. You have the answer to work on to apply to a bigger problem. If you know it, just plug it in right away. Integral of tangent is ln of secant, or negative ln of cosine. Okay. Then another trick, integral that may be helpful for your learning, is integral of secant. Integral of secant of x dx. All right. And let me first of all show you the book's method, because it's just quick, fast, and gets you to the answer right away. And the book shows you this way: integral of secant of x times secant of x plus tangent of x over secant of x plus tangent of x dx. So I'm multiplied by a dummy 1 right here. Secant x, tangent of x over secant of x, tangent of x. And I didn't change anything. So if I let u equal to secant of x plus tangent of x, then du, derivative of secant is secant x, tangent x, plus derivative of tangent is secant square of x, which is, factor out the secant x, you got tangent x plus secant x. So secant x and tangent x plus secant x over this. This is going to be equal to integral. The whole thing right here on the numerator will be du, and the bottom is u. So this is ln of u plus c, which is ln of what? Secant x plus tangent x, and then plus c. Okay? So, in short, the formula is saying this. Integral of secant x dx is equal to ln of secant x plus tangent x and plus a constant. Okay? So you know the way to solve it, and you can go through it, and eventually up to some point, just remember the integral. It's going to be helpful because later on you have to work on a bigger integration problem. So just know that in hand it's going to be saving time. Okay, and the question is, how the hell in the world we can, excuse me,